All right, in this video, we are going to talk about how to graph polynomials. And so the first thing we're going to talk about is the end behavior. And so I'd like to start with the even degree polynomials because we have a very familiar one, x squared, the quadratic. And so when our leading coefficient of a quadratic is positive, we know it opens up. And so we can picture a parabola opening up anytime we're dealing with an even degree and a positive leading coefficient. So even degree, positive coefficient. If our x squared is negative, we know the parabola is opening down. Okay, and so that's even and the leading coefficient negative. So just looking at the end behavior, it is going, as we go to the right side is going up. And as we go to the left side is going up. Okay, and so both the right side is up and the left side is up, pointing up. Okay, over here, as we go to the right, our parabola is going down. So right side is down. And the left side is also down. As we go to the left, it's also going down. Okay, and so that's going to translate to any even degree polynomial. If you have x to the fourth or x to the sixth, anytime you have an even degree polynomial, if the leading coefficient is positive, you're going to have both sides opening up. And so all kinds of different turns in the middle, but the ends will be pointing up. Whereas for a negative leading coefficient, as long as your degree is even, they're both going to be opening down. Okay, and so if we have an odd degree, we can picture x cubed. Okay, and so if our degree is odd, degree meaning the exponent, is odd, like 3, and the leading coefficient is positive, we can picture our cubic parent function that was up to the right and down to the left. We had that positive slope between those 3 points. And then if we had a negative in front of it, that slope between those 3 points would be negative. So it was up to the left and down to the right. Okay, and so looking at the end behavior, the right side was up, but the left side, as we went to the left, was going down. Left side was down. Okay, and then that situation is opposite whenever we had the negative. The right side was up, or the left side was up, and the right side was down. So right side is down, left side is up. Okay, and so that's gonna hold true for any odd degree. So anytime it's odd, the sides are not going to match. Anytime it's even, the end behaviors are going to match. So the way I like to remember that is I start with the right end behavior, okay? And so if you have a leading coefficient that's positive, and for the leading coefficient, we usually use A. So if A is positive, your right side is up. If A is negative, the right side is down. So focus on the right end behavior first, just by looking at the leading coefficient. Okay, leading coefficient. Okay, and so once you determine the right side behavior, if the degree is even, the left side will match. If it's odd, the left side will not match. It'll be opposite. Okay, so odd goes with opposite. Okay, and so let's just practice identifying. Okay, well, before we do that, let's talk about the zeros. And so remember, higher degree polynomials have multiple zeros. And so, for example, if you have a degree 4 polynomial, you're going to have 4 zeros. And so anytime you have a multiplicity of 1 for a specific 0, you're going to cross that 0. So if this is your x-axis, here's your 0, your polynomial is just going to cross right through it, kind of like a line. Okay? If your multiplicity is even, it is going to bounce, okay? And so if this is your x-axis, here's your 0, the polynomial is just going to bounce off that root. So think of like x squared. It would bounce. Think of just linear for multiplicity 1. It would cross like a line. Okay, and then odd degree bigger than 1, so you can kind of think of x cubed. If you have a multiplicity that's bigger than 1, it's going to twist. And so it is going to kind of look like that cubic inflection point. Here's your 0. It's going to have a change in concavity. Okay, so it's going to twist. Okay, some people call that flatten, because it's going from up, concave down to concave up, vice versa. Okay, so let's start with these factored polynomials, and then we'll go into taking it from the top and actually having to factor it ourselves. Okay, and so let's look at end behavior first. And so for that, we need the leading coefficient. And so we can imagine if we were to multiply this whole polynomial out, we would end up with an x cubed. We would end up with another x, and then we would end up with another x for our first term. Okay, and so that would be x to the 5th. And so our leading term would be x to the 5th. And so a is greater than 0. It's 1. It's positive, and so that means our right side is up, okay? And then because our degree is odd, it's degree 5, so odd means that the left side is going to be opposite. So right side up, left side down, okay? And so we can picture the left side pointing down and the right side pointing up. We don't know what's happening in the middle yet, but we will, okay? And now for the zeros, I know I would set each factor equal to 0, so this would lead to x equals -4. This would lead to x equals -2. This would lead to x equals 1. So at x equals -4, that's a multiplicity of 3. So that means it's going to twist, okay? Looking at this, odd degree means twist. Okay, x equals -2 is only here one time, so it has a multiplicity of 1, which means it's just going to cross like a line. And then same with x equals 1. It's not repeated, so it just has a multiplicity of 1, and so that means it's going to cross. Okay, so -4, and then -2, and then +1. Okay. And so I'm going to put the end behavior. I start with the end behavior. So we have left side down, right side up. So left side is down, right side is up. And then at -4, it needs to twist. Okay, so if you need to leave yourself a little room, it's going to have a change in concavity. And so it's going to be down and then up. So you can kind of flatten it out. And it doesn't matter how high up you go. That's something you talk about in pre-cal. And so just make sure it is twisting or flattening at that 0. And then at -2, it's just going to cross, so don't do anything weird. And then at 1, it's also going to cross, so don't do anything weird. Okay, so this is our twist, and this is our cross, and this is a cross. Okay, for this next one, imagining if we were multiplying it out, we would have a -x² times an x times an x. That would leave me with -x to the 4th as my first term. And so for our end behavior, we know that the right side is going to be down because a is negative. We have this -1 here. And then because the degree is even, that means the left side is going to match. Okay, and so we know it's going to be pointing down on the left and the right side. Okay, and then for our zeros, this would lead to x equals 0. This would lead to x equals -2. This would lead to x equals 4. At x equals 0, we have an even degree, so bounce. At x equals -2, it's just one time. and then x equals 4 is also 1 time. So we have 0, we have -2, and we have +4. So I'm going to start with the end behavior. Both sides are pointing down. And then at the -2, we have to just cross it. So cross. At 0, it bounces. And then at the +4, it crosses. It's kind of like a weird M-looking shape. Okay, and so for this next one, it's not factored for us, so that makes the end behavior easy, but we are going to have to factor it to find the 0. So let's start with the end behavior. Don't do anything because you have your first term here. And so the leading coefficient is -1. And so that means it's going to be right side down. Okay, so as x goes to infinity, that's the right side. That means y is going down to -infinity. Okay, and then because we have an even degree, the left side is going to match. Okay, so as x goes to -infinity, that's our left side. -infinity is to the left. Y is also going to -infinity because it's going down. Okay, and then for the zeros, we need to factor it. So I'm going to copy it down here. And then we see a negative in front. And so anytime you have a leading coefficient that's negative, you're automatically going to divide out a negative. And then since my last term isn't constant, that means we also have a GCF of x squared. We can divide out an x squared. Okay, and so that leaves behind x squared, just subtracting each of the exponents by 2, -x, and then -2. Okay, and so that's just a quadratic that factors to x minus 2, x plus 1. Still have this -x squared here. And so here's our factored form. That's going to lead us to x equals 0. And because we have a multiplicity of 2, it's going to bounce. We have x equals 2, which is just going to cross, only appears 1 time. And we have x equals -1, which is also going to cross. Okay, and so the zeros are 0, 2, -1. So -1, 0, and 2. Okay, the closer they are, the harder it is to graph it. So just do the best you can. And so both the right side and left side are pointing down. So we know it's looking like that. And so down, down. And then at the -1, it just crosses. And then looking ahead at 0, it bounces. So cross, bounce, and then our last one is also a cross. So kind of like the last example where it's got a weird looking M. And then for this last one, it says write the equation in factored form of the polynomial, hence use the given point to find the leading coefficient. Okay, and so looking at each of these zeros, we have 1, 2, 3, 4 zeros here. The -3 means x plus 3 is a factor. The 0, 0 means x is a factor. And then here we would have x minus 2. Here we would have x minus 4. Okay, and because at the 3 it is bouncing, I know that's going to be x plus 3 squared. Because at the x it's crossing, it's only going to have a multiplicity of 1. Here we have a twist, and so it's going to be at least 3. And then I always choose the lowest, so it says of least degree. And then here we're crossing, so just 1x minus 4. Okay, so I always put the x out front, and then we can put the x plus 3 squared, and then the x minus 2 cubed, and then the x minus 4. And it doesn't matter which order you put these in, I always just put the x first. Now, we don't know what the leading coefficient is, so I'm just going to put a as a placeholder. And then they give us this random point to give us an x and a y. Okay, and so y is 90 when x is -1. And so we can put -1 here, -1 here for all the x's. Okay, and so that gives me the equation 90 equals a, which is our unknown, -1. -1 plus 3 is 2, and we're going to have to square that. -1 minus 2 is -3, and we're going to have to cube that. And then -1 minus 4 is -5. Okay, and so that gives me -1 times 4 times -27 times -5. And if we multiply all that, we would get -4 times -27 times -5, which is -540. Divide both sides by that -540. And we get a equals -1/6. Okay, and so looking at this polynomial, to have a negative leading coefficient, it makes sense because right side is down, left side is up. Okay, and then looking at the degree of this polynomial, we have 1 plus 2 is 3, plus 3 is 6, plus 1 is 7. So this is a degree 7 polynomial if we were to multiply it out. And so the fact that our sides don't match is also making sense. Okay, and so our final answer would be -1/6 x plus 3 squared, x minus 2 cubed, and then x minus 4.